Hello, hello, hello. I know this is something that all of us here, Mary, Ryan included, have been doing as an opening statement, which is hello, hello, hello. But Ryan doesn't like us doing that. It's Ryan wants to make sure that it's a Ryan trademark to say hello, hello, hello. But I am really excited to see all of you here on the stream. From the States, I'm hoping it's not too early for you. If it is, you should definitely go get some sleep. Or if it's even too late for you, you should definitely go get some sleep. Hello, a lot of hellos here. I am really, really, really chuffed to see this. While I was coming into the stream, while I was prepping for this stream, setting things up, I was reminded that the last time I was here was maybe in September, if I'm not wrong. The last time I was here for was for Web3 opening, Web3 week opening, maybe just in September. It's been so long. I am excited too. Thank you so much. Someone's here from London. That's amazing. 6 a.m. on the East Coast, perfect my time. I know, but I would want to go back and get some more sleep. But if you don't want to, that's completely fine. But I'm really happy that you could make it onto this stream here from India. That's amazing. Oh yes, that's also been a talk of the town right now about the GTA 6 trailer going out. Have a lot of you watched that yet? If you have, can you tell me what you feel about that? Because this probably has been the longest wait for all the GTA fans, if I remember correctly. It's been a long time, and there's also a tweet that went viral on Twitter, wherein someone predicted the next or the sixth GTA will only go live in 2025, and they were quite accurate with that. And I think this tweet went out in 2013, if I'm not wrong. But how are you all feeling about that? Have you really watched that yet? That's also true. I agree. 10 years exactly. 10 years. Looks like the Miami map. Maybe I don't really know if they gave out a lot about it. Oh, personally, to me, I don't think I understood a lot about what's coming up. It probably streams seemed like just another thing that I was expecting from the GTA franchise, but it was nice. I don't know how you all feel about it, but I'm someone who's too much into flight simulators and stuff, and we'll get to that a little later. But I've specifically been looking at how the animation has been getting better each time a new version, a new chapter of each game or each software comes back. But this one was really, 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 really well done. I'm pretty sure you've also liked that and you appreciate that. Um, a lot of chatter here in the stream. I'd love to see it. Oh, Flight Sim Gam, I'm so happy that you're here. I'm probably the happiest today on this stream because this is probably the first time that I found anybody here who was able to relate to my liking to aviation, flight simulators, and all of that. And I'm pretty sure you're going to love that. I have a couple of other references during this stream. What topics are we going to cover? Thank you for reminding me to get back on track. But yes, thank you so much for joining. I wanted to give you all a very good welcome and wanted to also quickly understand before we get into this. To answer your question, we're going to look at very basic things of cloud, understanding where all of this came out from, understanding what the world looked like before cloud and what was the necessity to have something called the cloud, to understand if cloud really means the thing that you see up above on the sky. Is your data, all of your services coming up from there, or how is it really working? A couple of terms around it, so you're all set for the rest of the week. I'm pretty sure you attended, or all of you or most of you attended a lot of other streams that happened yesterday my time, or early day one of Global Hack Week standard time, if I can call it that. I'm pretty sure you were around for that and you got to learn a lot of cloud related things. But I wanted to take a few steps back in this session to kind of maybe set the premise for whatever you're going to hear of, whatever you're going to learn for the next of the week. And I can guarantee that the schedule is looking pretty good on my end. It's been a very, very, very learning filled week, or it's looking like a very learning filled week, if I can say that. A surprise that you can even that's for sure. And if you noticed the GIF reacts I sent, that all of that has airplanes and cloud together. I'm not doing just cloud, I'll do flights and cloud only. But that's super engaging, super fun. Here, let me quickly go ahead and introduce myself if you have not had a chance to cross paths, either on Discord virtually or in person at our in-person events. I'm sorry. I'm Siddharth. I work here as the first-party events coordinator. And when I say here, I work at Major League Hacking. Like I said, this is probably a couple of months later that I'm coming back to stream. The last time I streamed was for Web3 week opening. And like I said multiple times on the stream, I am an aviation geek, which means anything and everything that flies is what I am fascinated about. If you have anything to talk about aviation, aircrafts, anything that flies in general, this is exactly the session to keep the chat engaged. And you can also come back and make our off-topic channel really engaging with that. I know a couple of folks in this chat who send me pictures of really beautiful airplanes, pieces of art, beautiful pieces of art, I said, to keep me engaged too, and I really appreciate that. So that's exactly what we're going to do. But to come back to what we're actually going to do in this session, we're going to set a context of what all of these things are to understand what it really means. And like I said, we're going to talk all about cloud, understand what the chatter is about. But before we get there, let's make sure that all of you have checked in, because that's exactly something that's going to matter when you're waiting for your bonus swag. So if I can quickly share my screen and show you how that's done, the link is on your screen. If you go to hackp.ac, which we often call hackpack, /intro hyphen to cloud or intro hyphen to hyphen cloud, you're going to get to this page wherein you're going to see a register and check-in button. For now, if you've registered earlier, you're going to only see a button that says check-in, but you just have to click on that and then it loads for a little bit. And then if it says you are checked in, you're good to go. And then we know that you were at this session. So that also kind of gives us an idea of what you like watching, how has the community been liking the events that we do. So we are able to plan things better the next time we do something related to cloud or any kind of global hack week or stream later on. Well, let's just quickly make sure that all of you are check-in. If you can give me a yes or a thumbs up quickly in the chat, I can then move forward with what we're going to do in this session. I will use that time to go back and catch up with the chat here. Are we building anything in this workshop? Not really, because there's a lot of other sessions where you're going to actually code a lot of things. Like I said, I wanted to take a few steps back here to kind of set premise for what's going to happen or what really happened a couple of other streams that you've already been at and what's going to happen later on this week, give you enough understanding. And this is actually a very beginner friendly session. If you think that you already know a lot of this and it sounds repetitive to you, I'd still encourage you to stay back and maybe help people in the chat catch up with what we're talking about. And if you have any other insights of whatever we're talking about, any tips that you would want to share, any interesting stories about you hosting things on the cloud, any interesting stories about interesting hacks that you've seen, or anything at all related to cloud or outside of cloud, within communities and technologies or anything like that, just stay around and we'll make sure that this is a fun event for you as well. Going back to the chat to see if there are. I can probably say that was intentional, not an accident for sure, but I'd say it's a feature, not a bug. Let's call it that. For now, I see thumbs ups coming in. Yes, yes, yes. Da-da-da-da. I just quickly stop here to answer this question. Does anyone in the Africa region, has anybody in the Africa region received swag? I'm hoping this is, or I'm guessing this is a question because you have not received any kind of a swag item from us yet. If it's related to Global Hack Week, you can reach out to us at the email ID, which is globalhackweek@mlh.io. And I can quickly also drop that in the chat, which is globalhackweek@mlh.io. And that's the email that you can reach out to if it's anything related to Global Hack Week that you're waiting on. If not, you can also reach out to this email, which is shipping questions. So those are two email IDs that you can reach out to. I'll pin that again. So you know this is where you reach out to if you're waiting on anything Global Hack Week. This is where you reach out to if it's anything other than, if it's anything related to shipments and not Global Hack Week. That's that. I think everybody's checked in, a lot of thumbs up. Cool, let's get right into it. But like I said, a lot of setting the premise is what we're going to do here. And I wanted to use a little bit of an aviation reference here, a fictional story, of course, but a short aviation story to kind of understand why we do things on the cloud, like you see it happening today, and what really is the meaning of doing it on the cloud, right? So we're going to talk about a very fictional, bustling aviation hub called Erythropolis, which had a very, very, very big grand hangar. And if you don't know what a hangar is just a place where it's essentially a parking bay for aircrafts, and there's a lot of other things that happen related to maintenance, fueling, and all of that. It's basically the house of aircrafts when they're not flying. So there used to be a grand hangar at a place called Electropolis, where, of course, like I said, different aircrafts reached out with different needs. Some of them were just hanging around to kind of use it as a parking bay. Some would use it as a maintenance facility. Some others would come in for refueling. And they kind of made sure that, or the organizers or the people who set up this hangar kind of made sure that there were ground staff around through which these aircrafts not directly, let's just assume that aircrafts had power to communicate with real people. So the aircraft communicated their needs and accessed resources through ground stuff. And I also wanted to really pause here and say all of the pictures that you're going to see, or most of the pictures that you're going to see here, is purely stable diffusion generated. If you don't know what stable diffusion is, it's a text to image generator. And I was really surprised while I was playing around with all the different modes that you can use on stable diffusion to see how well these images turn out to be. And I'm pretty sure you'll also encourage or appreciate how well all of these things look. Going back to the chat just to make sure I did not miss any last questions here. I am sorry if you hear any kind of background noise. I'm just too close to the highway here, so it's a little busy. I'm really sorry if you really hear a lot of noise. I'd also recommend turning down the volume a little bit down if you think the noise is too much. Sweet. So that's about the first part of the story where we talked about the hangar and all of that. Moving on, this again is a image that was generated by stable diffusion. So there happened to be someone called as the hangar manager, a person who's a dedicated individual overseeing operations, manage the hangar's resources, schedule maintenance, and ensured smooth operations of the aircraft. So this is a person who's looking after the day-to-day operations of the place. Now, an important part of making sure this place was successful, or the grand hangar was successful, in all the senses. One, financially, of course. Second, that the productivity in terms of how things were used was also kind of, let's label it, productive. Adaptability was an important point to look at, and adaptability was pretty evident at this place because the hangar manager did a really good job in juggling schedules and resources when certain bays weren't occupied, which reflected the dynamic allocation of resources. And of course, this place had security personnel around for to ensure safety and adherence to protocols. Now, you ask why security here? You would want to set some sort of a access control, which says only people with certain roles are allowed into the cockpit. Or let's just say this is a hangar where the Air Force One, which the US president uses to travel, or the Air India one, which the president, vice president, or the prime minister in India used to travel across the globe. If there were flights like these, there were airplanes like these which are parked in there, you wouldn't want people, or you wouldn't want everyone to kind of walk around this and maybe cause some sort of a security threat later on, right? So safety was also a very important part of making sure this place worked well. Now, what are some important points to note? And you may have noticed these phrases I had in bold over there. One was customers have different requirements, which means people come in with various needs, and you need to kind of make sure you're able to meet their requirements in a specific turnaround, let's say, and also to make sure they get their resources when and how they need. Adaptability. I also want to expand on that by saying adaptability can also mean scaling and shrinking. Let's take the example of what we already talked about, which is the resources inside of the bay being used, uh, the way it was used well. Whenever there are people who let's take a broader example here. Let's just say that there was a parking bay which typically was always booked for a 24-hour period, but for one fine day an aircraft decided that they just want to use it for 16 hours. So the buffer time that we have of 8-ish hours, I think, would be a time that other aircrafts can come in and use. If we were to kind of shrink and scale the needs, or kind of adapt to the scaling and shrinking of the needs there, right? That also is something that we had to note, or we should be noting from this example. Communication, of course, communication, like most of you might have already guessed, is APIs in the world of software. Well, you kind of establish an API between one entity and the other to meet separate needs. Security protocols, we talked about that. And then the other important thing that I wanted to kind of point out here was the concept of renting, or the concept of pay as you go, is typically cheaper than on-premise setup. Based on the example that we chatted about earlier, imagine that every aircraft in the world, or every let's just say every airline company in the world had to set up their own hangars. It would have been a logistical nightmare for them. It would have been financially a very big of an overload for them. It also wastes a lot of space because not every hangar would be used as much. If you have a common place where people are able to come and use it as they want to, it kind of is cheaper also to the folks who are using it, right? For the clients or the customers who are going to use it. Now, let's just quickly jump on to kind of talk about why do we use internet and what do we use the internet for. And while we talk about that, let me go back to the chat to see if I missed any questions. Generated with DALI, not really with Dolly, but this is another thing called stable diffusion that's actually open source, and which is exactly why I wanted to use it. I'm a big advocate of open source. If you've been around for other sessions, you would have seen me talking about that. But stable diffusion also does what the other model that you're talking about does, but it's completely open source. Yes, and you can just go to their website. This one here. Thank you so much, 404, for dropping that. You can just go to this website, and there should be a button called use it for free or try it for free, I think. Click on that, put down your prompt, and it's pretty simple, and you can play around with those things. Cool. Looks like the chat is all set with what we're talking about. Now, going back to what do we use the internet for, and I think it was not really helpful to have a slide here talking about why we use the internet. All of us really know what we use it for, and I've really just labeled four things, so we kind of are on the same page that we agree we use these four things for, and then that helps me move forward with this presentation. But other ideas of why we use the internet, what we use it for, just drop it in the chat, and I can come back and we can discuss about that. But essentially, we're using a lot of resources. These resources are not just computing power and storage and all of those complicated things that you're going to hear about what and how cloud helps with, but it's very simple basic things such as watching a stream here on Twitch or YouTube or wherever you're watching, me using a platform called StreamYard to get to all of you during the stream. Can be any sort of a financial service that we're doing. Can be any kind of social media. That's something that all of us really spend a lot of time on. All of that is kind of a resource that's set up somewhere on a remote computer, and we're kind of accessing it without the boundaries of a physical or a geographical location, right? Next up is collaboration and remote work. Collaboration can be as simple as us setting up a Google Doc. You open up a Google Doc, share the link with your friends, and then all of us kind of are working on the same report, let's say, on the document, and not one person's mistake is going to mess up the other person's work, right? We're all working on the same document essentially, but we're able to kind of separate our spaces and work through all of that. Version control, I also just wanted to point that out because GitHub is probably something that popped up to your minds when you heard of version control. That's also something that we use for, and as hackers in the community, you've probably also used GitHub at some time. And I think you also have a session coming related to GitHub, if I'm not wrong. So you can hang around and learn more about GitHub if you've not really heard of that yet. And then generally, probably generalize all of that together. It's learning, research, development, all of that we do, or maybe pastime on the internet, right? That's all we do together. And when we do that, knowingly or unknowingly, we use a lot of cloud infrastructure, because all of these things that you use today are set on the cloud. So it's really important for us to maybe understand what it is about, how did it really come up, and does it really impact you? Is it something that you should deep dive into and kind of start learning or kind of start exploring or experimenting with, right? We talked about a lot of things. Now this is exactly where we're going to now talk about what exactly is cloud. If I were to pick a definition straight from the internet and kind of simplify that, it looks something like this. Cloud computing refers to accessing and storing of data and providing other services over the internet. We talked about social media, storage, streaming, email, finance, and all of that being services that we use. But the main thing to note here, and we also talked about it while we were talking about the aviation story, that the data or the services that you access are not, or probably not, owned, set up, and maintained by you. What sets it apart from other kind of architectures that we're going to also talk about in a little while. And you kind of pay to access it. So if you were to use the Google Workspace, let's just say email being part of the Google Workspace, Drive, your Google Photos, and all of that, uh, you kind of use the free tier for a long time because the free tier has a lot of space for you. But then when it starts exhausting, you will now start paying for if you want additional storage space, right? So you pay for it essentially. If not right now, maybe in the future, in the recent future, you will start paying for it. And it's also adaptable to how much you want to use it. You don't really have to pay for everything and anything that you don't really think you're going to use essentially. But there is some sort of a shrinking and scaling that you can do typically on a cloud infrastructure, and we'll get on to all of that. Taking a quick pause here to kind of interact with all of you and understand, have any of you used cloud in some sense? And I'm looking for examples of, hey, I use cloud for maybe this particular use case, or I used cloud, or I realized I was using cloud, or I thought this is a very fascinating use of cloud when I was on this website or at this web page, anything like that. Oh, that reminds me, while we were talking about GTA, there's this specific time during early COVID, I think, when it was a complete lockdown in most of the countries and everybody was home. I think it was esports or one of the popular companies who decided to give out a lot of free games, access for people to a lot of these free games, a lot of popular games where you could use that through cloud. As in, you can just go to their website, uh, hit a button, hit a random button, and then you can start playing, or you can download that and all of that. So where do you think all of these games were stored when hundreds and thousands of people were reaching out? It was there somewhere on a remote computer where people were downloading it from or using those resources, right? Another interesting concept there that you can think of is called load balancing. So when these games were made available to a very large audience, I'm pretty sure lakhs of people or hundred thousands of people were reaching out to these servers, to these websites to make sure they were able to access that resource, right? Uh, so there's a concept called load balancing behind the scenes in cloud, and I know I'm jumping the queue here to get to a lot of other interesting things that are just popping into my mind. But there's a concept of load balancing wherein there are several servers that are ready to answer to your request and get you to fulfill your needs, and then uh, cloud technologies kind of decide, hey, this server is getting overloaded, just redirect this request to a different place. And that, I think, is what I can tell you about how I really find this cloud infrastructure really interesting. And I see some things coming here into the chat. Let me go back and read and pin them for you to read as well. um, 404 used cloud to train AI models, Kaggle, Google Colab. That's true. And I don't know how many of you have used Kaggle, Google Colab, all of that good stuff. But if you've used Google Colab, that's where you can just set up things. You don't really have to install anything. It's just going there, writing down all of your data science, AI, ML code, and you can just start running it. The good or the most fascinating, interesting thing about it is that you can use a CPU behind the scenes, you can use a GPU, you can also use a TPU, and that's just a button click away. You can just click on a drop down, choose GPU as an instance that you would want to run, and Google Cloud behind the scene assigns you a GPU or a TPU uh, for your use case to kind of train on. Because as you would have noticed, AI/ML is a very compute intensive thing to do, and storage intensive as well, because you need a lot of data for your models to be trained on. But that's a really good example. Thank you for that. Cloud gaming, yes, we did talk about that. Da-da-da-da. Hey, you're not late yet. We're just getting started. We were just talking about maybe a very boring aviation story that most people in the chat can't relate to. But we did a really brief talk about what cloud would look like if you were to Google, or cloud's definition would look like if you were to Google. But we're just getting to the history about those things here. Uh, there's someone who deployed their backend on Vercel Heroku. They did for us on AWS. That's amazing. You've used the power of cloud already. Computational engines, yes, exactly. That's what we were talking about. Some of our global servers are for to serve regions, right? Regions, yes, is a very interesting concept. Regions is basically, and I'm not 100% sure if certain regions don't get certain features in a cloud, because I don't think I'm quite updated there. But regions, yes, is a very interesting concept wherein you would want to make sure that you select a region for your cloud services which is closest to where you expect your customers to be. So your services, your requests don't have to travel all across the globe to the other corner of the world to kind of answer your requests and all of that. Yes, region again is a very important and a very interesting thing here. Uh, Interesting question. Can you push a Google Colab work onto GitHub? Not that I know of. I don't think there's a plugin like that where you can hit publish or deploy, or I don't know what it can be called, but I don't think there's a one-click way to do that. You probably have to copy paste to get it into there. Or if you want to do something like that, I think Kaggle is a better place because you can, if I'm not wrong, you can store all of these as notebooks, and other people can come and look at your work. So Kaggle is a place where AI, ML, and data enthusiasts stay. So you probably want to also explore that. But to answer your question, I don't think there is a way to do that directly. And I can see all of you getting together to learn different things. I am really happy to see that, and that's exactly what we try and do here at Global Happy Extremes. Really, really, really happy that's happening. Does system admins play a role in cloud computing? From what I know, system admins do play a role in setting up infrastructure for their organizations, and that I'm pretty sure has to do with a lot of things that you have to set up on cloud. So I think yes, I probably am not the right person or the best person to answer this question, but I think yes, there is a role that they have to play. Or I think pretty much every role in the software field right now has something to do with cloud. So I'm pretty sure they'll also have something to do because their name says system administrator. Um, Da-da-da. Sweet. A lot of interesting things there. Of course, yes, you can export things as an interactive Python notebook, which is the short for it is IPyNB, and you can get it onto GitHub. Yes, you can always do that. Export and upload as normal. Sweet. A lot of interesting things there that I could have never thought of if I were to list that down on a slide. But thank you so much for doing that. Let's just go quickly talk about a little bit of a history of how all of these evolved. I have 6 things that I've labeled here, but while I was doing this and while I reached this slide, I was like, hey, there's also a 7th thing that we need to talk about, which is not actually the 7th thing, but the first thing that should have been on top of distributed systems, which is the regular client server architecture that we see. Now, if I were to give you a example of what client server architecture would look like, I saw a couple of chat in the a couple of mentions in the chat about backend. So I'm expecting some of you have worked with a hack at some point, have built a hack at some point, and you know what a front end and a back end would look like. So let's just imagine that you're building something on your laptop, you're using no cloud technology or no hosting technology as such. What you do is you set up your backend, you set up your server inside of your local machine. You also have your front end inside of your local machine. So whatever requests come in from the front end are answered by the backend that is living inside of your system, right? So that is a typical example of a client server or a front end back end architecture, a one-on-one or one-to-one client server architecture, right? I think it's worth mentioning that things started from there, where somebody was like, "Hey, we need a client and a server. We need to kind of modularize this. We need to have 2 different things: one which sends request, one which does all of these computations, well, does all of these request fulfilling, sends it back to the client or the front end, and then shows a lot of things, right?" So that's probably where things started involving or evolving. And let's think of uh, a very unsmart client server architecture where there's one server that can only and only cater to requests from one client at one time. So there's no multi-channel. There's one client who kind of signs up or logs into this server, gets all of these requests fulfilled, and only after this client has logged off or disconnected can other clients come in and sign up, right? So that we'll start from there. That's the first step, which is a client server unsmart architecture. Let's call it that. We moved on to something known as distributed systems, which is basically a collection of interconnected computers that can communicate and coordinate their actions to achieve a common goal. So it's not just one server that's doing a lot of computations. It's a lot of interconnected computers, a lot of interconnected servers that's trying to kind of speed up this process of fulfilling requests, right? But with distributed systems, particularly at that time, the problem with it was geographical locations, because it required for them all of them to be in the same geographical location, and we weren't that smart enough at that time with web 1.0 that we really understood why we would want to have things available over the internet, and we probably also did not have that infrastructure to get things done that way, right? that resulted into something called as the grid computing. Or there's other things that came along, which is cluster computing and all of that stuff. But to keep this short and to keep this kind of meaningful to the topic, the cloud topic that we're going to discuss, or we are already discussing, I kept it short to just have 6 points here. So grid computing essentially was the same concept of distributed systems, but this right here was computers which were placed at different location, different geographical locations, and they were all connected via the internet. Now, the problem that came in there, or a very logical problem, and somebody in the chat already pointed out that problem, which was about regions. Now, when you have a lot of computers at different places connected via the internet, the increasing distance between who's asking questions and the server who's answering your questions can become a problem. And several problems did come up because of the increasing distance. Let's just put it that way. Next up came something that was very, very, very important for how cloud developed, which is called virtualization. Virtualization is a technology that allows you to, and if I were to to simplify what virtualization is, if you've ever used something called as virtual machines, you would really understand what virtualization means. If you've not, let's just put it that this way. If on your machine that you're watching me right now, if let's just imagine that you're all on your laptops or your personal computers, uh, if we were to set up several different independent machines, in the sense that all of these, and let's just call them virtual machines for now, one virtual machine has its own operating system, but all of these virtual machines are sharing the hardware that's on your computer. So let's say my computer here has 8 GB of RAM and let's say 512 GB of hard disk. Now these VMs or these virtual machines kind of split up the hardware internally, but have a separate and independent existence. So if one virtual machine was to get corrupt for some reason, it will never affect other virtual machines. And if you now are trying to relate to the concept of cloud or have ever used it, you will now understand why it was important. Because ultimately, essentially, I also was reading through the Discord chat and found people saying, hey, you're ultimately using someone else's computer and not your computer. That's pretty true. There's no saying no to that. So there had to be someone who came up with this concept and said, hey, you can still use this computer of yours and sell your computer's hardware as a service. And that's exactly how virtualization evolved. Next up is something called Web 2.0. Coming back to the chat really quickly to see if you have anything. Ta-da. Is distributed computing a subset of cloud computing or a different thing altogether? You can pretty much say it's a subset, because there are certain things that all of these 7 things or 6 things that we're going to talk about, or we already have started talking about, have that were brought together. Let's just put it this way: all the advantages, all the pros of these 6 or 7 things were brought together to build cloud computing. So if you think of it, yes, it is kind of a subset of it, but this is how the journey looked like, and people got smarter, technologies got smarter, and ended up being a cloud, or being called the cloud computing, I would say. Good question there. Um, One of the main goals of distributed system is availability. Yes, of course, it is. If one of those servers or one of those distributed systems or one of the systems in the distributed systems were to go down, the others will still survive and make sure the requests were answered. That is accurate. Cost is also a factor of how cloud came to be. If you remember the other example, the aviation example we were talking about, we did kind of do an analysis of how cost played a role there, and how renting or how pay-as-you-go infrastructure was very helpful in coming down to a cloud setup altogether. Scalable cloud computing, yes, of course. Sweet, you are doing a very good job. I get a good vibe from the chat every time I look at it, because all of you have so much to contribute. It keeps it really, really interactive that way. We stopped at Web 2.0, and we stopped for all the right reasons, I would say. I wanted to maybe show you a quick glance of what Web 1.0 looked like. And if you don't know what the difference between 1.0 and 2.0 is, we've now uh, come into the future where we're talking about 3.0, 4.0, and all of those things. But I don't think we've talked about 1.0 and 2.0 as much. So Web 1.0 is where probably web was born. And we're talking about static web pages where you can't do a lot of things on a web page. It's completely static. Web 2.0 was where we really got into more interactive and pleasing pages. All the things that you see happening on a web page right now, or a web app I should say right now, is how is probably born because of web 2.0 as a concept came into picture. And to make it more relatable, this is how something in the web 1.0 land looked like. This happens to be a browser called the Netscape Navigator browser, one of the earliest browsers that were known. And you can see how, I don't know if it's the right way to call it unsmart, but you can see how limited resources were back at that time and how limited technological advancements were at that time. There's not a lot that you can do. It's pretty much uh, I don't really know what the right word to explain here is, but I think you understand what I'm trying to get here. We evolved from here to all the really, really, really fancy websites that we can build right now. So I just wanted to quickly stop and give you uh, maybe a brief of what it looked like. Throwback to the 90s. Yes, that's probably the best way to do it. Netscape, the legend, of course. And I think the other website that you can go check, and this is also a good task for us to do sometime if you get some time on the stream, which is we can go back to the Wayback Machine. I don't know how much of a way back the Wayback Machine can go, but if we were to go back to somewhere in the 90s and look at all of these 90s or 80s or even farther away, we can go back and look at what these common websites from today look like and kind of compare what it looks like right now. We can do that. Or if anybody is interested in doing that, if you don't get some time on the stream, if any of you are interested in doing that, and if you want to maybe start a thread on the Cloud Week channel, I'd really appreciate that. And we'd make sure we also feature you or all of your work, all of your comparisons when we do the Today in Global Hack Week stream later today. So if you want to do that, we can really do that. I'm really super excited. If anybody's interested, we can get along and we can do that later. But thank you so much for pointing that out. I love that idea. Um, Netscape, ancestor of Firefox. I'd say ancestor of everything in this browser world, because I don't think anybody existed, any browser existed when Netscape was doing the job really quickly. Static web pages was 1.0. That is absolutely correct. Sure. So we now have an idea of distributed systems, grid computing, virtualization a little bit. Web 2.0, yes, we understood that Web 2.0 also had a major thing to play, because on a typical cloud infrastructure or a cloud web page, if you were to go to, let's say, Google Cloud, AWS, Azure, all of those things, and look at the screen, the web page, it has a lot to fulfill, right? And that can never have been fulfilled with 1.0 back then. Next up is another very interesting thing, which I also probably discovered very recently, that there was a word called service orientation to all of those things. Service orientation is, in the context of web, of course, refers to an architectural approach that emphasizes the creation, use, and interaction with services as primary concepts. Now, let's simplify what that means. We've all heard about making code that's reusable, making sure that you promote modularity in your code, making sure that the pieces of code in your software is loosely coupled. All of that put together is what's called service orientation, and that's something that I recently figured there was a word to explaining things. So uh, which was later, or which is in the recent past, that people understood why things shouldn't be really tightly coupled. So if there's one thing that goes wrong, you're able to at least debug things fast. You're able to kind of identify how things are. That kind of now evolved to what are called microservices and all of those things. And all of those good things that we see in the software world right now started because someone coined this term called service orientation and emphasized on the fact that we should promote modularity, reusability, and all of those things, which was quite interesting. The last thing on the slide is called utility computing. Now, if you were to think of utility computing, this is exactly what we talk about when we talk about cloud, which is making sure that services can be shared using internet. Now, the services can be processing power, storage, and all of that. So utility computing is exactly where people really started using that term and exploring this field of sharing things over the internet as a service. When we'll get to what services are later on. But this is another very interesting thing, which I don't know how many of you have read of, or how many of you know this person who's labeled in bold here. But just to quickly read through what this person said. This person said, computing may someday be organized as a public utility, just as the telephone system is a public utility. And this was said by Professor John McCarthy. I don't know if you've read about this person, but if you're anybody who's interested in the field of computer science or uh, has anything to do with computer science, I really think you should go read about this person. This person has a lot with to do with any and anything and everything that we now learn of as a recent technology. AI also included is something that this person worked on in the early days of it, and kind of also coined a lot of terms that we very easily now use in today's world. And specifically in this context, while this person was talking about computing being organized as a public and utility, this was happening in 1961, and this was definitely an alien concept to everybody at that point. People were people I'm sure weren't believing anything that this person was saying. He even went ahead to say each subscriber needs to pay only for the capacity he actually uses, but he has access to all programming languages characteristics of a very large system. So certain subscribers may offer service to other subscribers. The computer utility could become the basis of a new and important industry. And this was way back in 1961 when things had been evolved. And this person, I would really encourage all of you to go Google and read about John McCarthy if you've not yet, to understand how things worked back in the day. Now, this was 1961 when this person just spoke of it casually and maybe also was doing some sort of research behind the scenes. We would never know. But in 1999 is when Salesforce, you may have heard of this tool called Salesforce. Salesforce actually launched something in 1999, which was a software as a service. We'll get to those terms also, but if you know what that means, uh, they launched their customer relationship management tool, which is called the CRM tool, also in 1999, and that is believed to be the first implementation of the cloud infrastructure that we know of today, and specifically related to the software as a service thing. Now, it was only in 2002 that AWS came into picture, or Amazon came into picture, I should say, and started their AWS just for storage and compute. We know they do a lot of other things, and all the other cloud providers also followed afterwards. So it started in 1961, or we can say somebody talked about it publicly on record in 1961. 1999 is when things actually started taking shape. And then we know how things have evolved now, where each one of us is using that in some way or the other. Just quickly stopping here before we get into a couple of other last bit of topics here, to see if you have any interesting thoughts about this. While we're chatting about that, did anybody go back and search about John McCarthy to figure out anything interesting about that person? I know there's plenty that you can find out about that person's work, a lot related to computer science and mathematics too, I can say. What can be an example of utility computing? Online compilers, anything and everything, I can say. So, utility computing was just a concept of being able to use things or use services over the internet where you're sharing it with someone else, and that's exactly what we're doing with your Google Docs, your online compilers, to anything that's available online. We're just accessing that service over an internet. We have no really no control over it in some way. It's hosted somewhere else on a remote computer, uh, and we probably pay for it as we use it, right? So it's everything and anything, I can say, is part of utility computing. It's just that the word was coined at that time. Hello, nice to have you here. So I'll give you a little bit of more time to catch up while I go back and scroll through the chat. Uh, Sweet. Looks like everybody is caught up. Now, a couple of really seems interesting. I hope so. I hope, really hope everybody else is also finding this interesting. But let's just get into a couple of last bit of things here, which you're going to hear of maybe all throughout the week and rest of your software journey, which is to begin with deployment models. And we're essentially going to break this down into three different deployment models, which is a public cloud infrastructure, a private cloud infrastructure, and a hybrid cloud infrastructure. So how do we really understand what public cloud is? As the name suggests, services are provided over the public internet, and anybody can really access this. A common example is whatever we do on our cloud platforms, the Google Clouds, Azure, AWS, and all of that. But let's just use an example or draw an analogy with how we travel to work or how we travel to our schools, right? If you were to think of how we travel to schools in terms of or something related to public cloud, I'd say we use a bus that's open to general public. That's how public cloud can be related to. So a bus that's not restricted anyway, it's on the public cloud, or it's open to anybody who's a resident of that place, or a or is present at that place and needs it, to put it like that way. That's what public cloud means, right? Moving on to private cloud, right opposite to that, infrastructure and services are dedicated to a single organization and can be hosted on premise or by a third party provider, and offers greater control, of course, because it's private. There's more things that you can do with it, and it's for a restricted amount of crowd. To maybe briefly stop and talk about what on premise and third party provider means. This is also a comparison that we did a while ago with the other aviation story. While we were talking about that hangar, and the aircrafts, we were talking about how somebody decided to kind of build a hangar for other people to use it. And if other airlines decided to build one for themselves, the cost is going to go up for them, right? So if I were to decide today that, hey, I want to start a software company, and I am going to have all of the infrastructure hosted on my premise just for me, that requires me to set up the infrastructure completely, maintain it, make sure it's prone to any kind of um, um, it's not prone to, you should say, any kind of security threats and all that, right? So I, as an individual, or my company as a whole, has to take care of a lot of things if I were to have this on premise. But if there's a third party provider like Google Cloud that I can just spin up and use whenever I want to, and not really waste a lot of power, a lot of compute that I have in store and I don't really need, I don't have to worry about all of those things when I do that, right? And how do we draw an analogy here? This can be a car that I own, that I drive to work, using, or I use that to drive to my school, right? That's how I'd explain private cloud. And all of these leading cloud providers that we talk about have a way where you can set things up only for your organization. So it's protected that way. And it's only available to people who are trying to access through the organization's network. Okay. Now comes a way for us to set up something hybrid, which has all the good things of public and all the good things of private cloud, which means essentially integrating both public and private clouds, allowing data and applications to be shared between them, offers flexibility, scalability, and ability to move workloads between the environment. I know that sounds really complicated, but a really good example is a taxi that you hail to get to a place. And this can be work or school, like we talked about, which is, the taxi is still available to anybody and everybody to do it. But while you are in the taxi, it gives you a feel of your private ride. It's not like a bus wherein you use it, but you are not the only person who uses it. There's other people inside a bus who use it. But for a taxi, it's not owned by you, but you just get it when you need to, and for that period of time, it's yours to kind of decide where you want a taxi to drop you off, right? That's how we talk about that. Coming back to the chat quickly to see if we've had any other discussion about that. What did I miss? I'm guessing we're talking about John McCarthy. Yes, PhD in mathematics. I think that's accurate. And there's more to read. If you're anybody who's interested in reading about computer science history and all those things, you should go definitely check that out. Uh, uh, Privately price out and keep it, and it doesn't dissipate. Well, that's a secret for you to find out and let us know. We'd be waiting for you to tell us how you managed to do that. Private cloud, very much personalized. Yes, that is accurate. I can see us joking about 404's question here. Amazing. Sweet. I'll let you all do that, and I'll go back quickly to get to the next thing that we had to chat about, which is cloud services. And we've all heard about something as a service, X as a service. And I just wanted to break down three things that you're going to hear: infrastructure as a service, platform as a service, and software as a service, and kind of just understand how all of these things are set apart. To be very honest, these are not just the three things that you're going to hear of now. There's a lot more that's happening. You may have heard of blockchain as a service if you've decided to get into Web3. You will hear of authentication as a service if you've explored some sort of cloud there. There's a lot of X as a services that are available to people now. But infrastructure, platform, and software is what we always discuss when we are really just getting into cloud as a whole. So we'll just get into that quickly. And yeah, that I think should be pretty much it for this session. So, starting with infrastructure, as the name suggests, it provides you with virtualized computing resources over the internet, including virtual machines, storage, and networking. And I'm hoping all of these terms make sense to you because we talked about a little bit of virtualization. We kind of understood what compute is, what resources are, what virtual machines is, storage, and networking. But please feel free to drop. I'm sorry. Please feel free to drop your questions in the chat if you have anything to talk about. But I'll keep continuing if not. I'm sorry. Um, of course. So infrastructure here, our examples of infrastructure here is your EC2 instance on an AWS. It may not make sense to you if you've not used this, but feel free to ignore all of these examples if you've not used this because it's too specific to a use case here. But if you've ever used any sort of cloud provider or specifically the three that I've mentioned here, you would know. If you've been on the AWS land, you will know what EC2 is. If you've been on the Azure land, you will know what Azure machines are. If you've been on the Google Cloud, would know what Google compute engines are, right? But you can just Google and find out what infrastructure as a service, and it's not a big deal. It's just very easy things that you need to know of. But just understand that the whole infrastructure is for you to kind of set up, decide, and maintain. Moving on, platform as a service, it's kind of a subset of infrastructure where you kind of only are taking care of developing things, building, deploying, and managing applications without dealing with the underlying infrastructure. It provides you with tools, middleware, and development environments. And we're talking about, and I think I remember someone mentioning the chat that they've used Heroku, and that's exactly what fits into this class of cloud services, the platform as a service specification. Heroku is a good example. Google App Engine is also a good example if you've used that. Sorry, I'm really going fast through all of these things. But if you have questions, please put it here because these are like self-explanatory and you just need to really use all of these things to get a hang of how these work. And I'm pretty sure there are a lot of sessions that are going to happen throughout this week where you're going to use some of these things, deploy your code, understand how software as a service works. But this right here is just an attempt for me to give you a baseline of what all of these things mean and how it's going to help you in this journey, right? Ta-da. Sweet. The questions also, chat also looks a little silent. So I'm assuming you're still catching up here. I'll go back to the slides and we can really talk about other things. Last but not the least, we have to talk about software as a service, wherein these software applications over the internet are on a subscription basis. Users can access applications through a web browser. Now we are talking about few things that we already discussed, which is a Google Workspace, your Microsoft Office suite, and all of those things, right? You are really using these things as and when you want to. You're just using the software. You are not bothered of what the platform is capable of. You're not bothered about maintaining the platform. You're not bothered about setting up the infrastructure for it. You just go type a URL on your web browsers. It gives you something, you use it, and then you forget about it completely, right? And like I mentioned, there's a lot more outside of this. There's blockchain as a service, authentication as a service, database as a service, all of these as a service concepts that have come out later. But just for the scope of this introductory session, those are the three things we're going to talk about. And to give you a visual idea of what it looks like, and this is an image that I got from Red Hat's blog about cloud computing. You can also Google and get there. This gives you a better idea of how these things are split. So if I were to have everything set up on my site, I'm taking care of pretty much everything from applications to networking, storage, servers, security, all of that. That's what I have to completely handle. Moving on to infrastructure as a service, I handle applications that are on it. I handle the data that's going in and coming out or exists inside of it, the runtime, the middleware, the operating system. That's what I take care of. The virtualization, server, storage, networking is still something that someone else does for me, probably a third party who's handling that for you. When I come down to platform as a service, it's just the applications that need to be set up somewhere and the data that exists on that server or is coming in and going out for some use case that I'm trying to build. That's the only thing that I am really worried about when I set up something in the platform as a service interface. Moving on to software as a service, I'm really not bothered about anything here. I just come here, go to a web page, do what I need to get things in the shape that I want it to be, and then go. So if I were to use Google Docs today, I just go into Google Docs, put some things in, prepare a report if I'm doing that, export it as a PDF, print it later to go maybe send it to my coworker or my colleague or anybody like that who needs it, and then I just close it. I'm not bothered about uh, setting up the application, making sure that the resources have been allocated to someone else when I log off. None of those things, right? So that's exactly a brief of how all of those things work. Just one quick thing that we need to dive into is a concept of virtualization, how it really works here. And I know some of you here in the chat will be excited to read about pizzas. If you've already read through the slide, you would see a pizza mentioned. And we also have a pizza emoji and a sticker live on our Discord server recently. I don't know if that person is still around who would want to. That is true. 404, we're really excited to do that. But I wanted to again use a very common example, a silly example, maybe to kind of really wrap this up session with virtualization that we really already talked about. Imagine you have a single pizza and everyone has a different topping they like on each slice. You've kind of cut that pizza into slice and have given people an option to customize their slice however they would want it to be. Uh, and I know I was going to say if somebody wants to have pineapple on their on the slice, they could also have that. But I think people in the chat are going to call me out if I said that. But whatever you would want to have as a topping on your slice, you can do that. So this is kind of the idea of virtualization, where you kind of split things up according to your needs and customize it, but the whole purpose of it really remains the same. uh, I don't know how to react to this, but there's someone who wants mango on their pizza. We'll figure that out. We'll wait for the chat to catch up and tell us how they feel about mangoes on their pizzas. I may not be a very big fan, let me put it that way. But now to kind of bring it to a real world scenario, we did talk about virtualization, wherein we are splitting a computer into smaller separate parts called virtual machines. Each virtual machine acts like its own computer. Remember, it acts like its own computer. It's not really a physical complete computer that you've been assigned. It's just a section of it, but it looks like it's a complete computer because you have your own operating system. You have the storage that you asked for, you have the RAM, the hard disk, and all of that things that you asked for, the network capacity and all of that. But you are in reality sharing a space with other virtual machines, and the space that comes out is out of a physical hardware somewhere, right? And of course, if one VM has a problem, it doesn't affect, or doesn't ever affect, I should say, the others that live alongside. How is this made possible? And this is exactly something that we're going to stop at, which is called hypervisor. Hypervisor is what makes the virtualization dream come to reality. It's not a dream anymore, but probably when people were still talking about virtualization and did not know how to fulfill this, hypervisor fulfilled the dream of making sure virtualization was able to come into picture. Looks like 404 is in the chat and you've taken a screenshot. Appreciate that. We're going to get to 404 later on Discord, and we're going to let 404 know that we did this. Uh, nice, yes. So getting down to hypervisor, and that's the definite end of our stream here. Hypervisor, I just skip to the next slide and then we'll come back to give you idea of what it looks like. Hypervisor is a software which lives somewhere where you can see on your screens right now. And the three sections that you see on top are three different virtual machines wherein there are applications running on top of an operating system. So let's just say three of us decided to kind of make virtual machines for our use cases. We have operating systems of our choice running on it, and we install very different applications on it for very different use cases. We've been using that. There is something known as a hypervisor, a software called hypervisor, which has taken up the job of splitting hardware and assigning it to these virtual machines so they're able to do the jobs they're meant to do, right? This is how the architecture looks like. Let's go back to the other slide and read through all of the things that the slide had. One, we talked about virtual hypervisor being made possible because of the software, or virtualization being made possible because of a software called hypervisor, special software that sits between the hardware and the virtual machines. It divides the physical resources of the computer into smaller parts, allocating portions of the CPU, memory, storage, and other resources to each VM. And that's exactly what we've been using on a daily basis, or talking about in the 20 odd slides that we covered, wherein we are trying to split things up, making things available over the internet, and people make use of that as and when they want to. Going back to the chat one final time to see Many questions. Ta-da. Oh, just had to install one for my last course, hypervisor VM. That's amazing. If you have any resources from the time that you were learning about them, if you have any insights to share, please do that. I am pretty sure people would be really interested in exploring more and to kind of understand how it works and uh, really understand to kind of get their hands dirty and to set this up and all of that. So if you've any resources that you want to share, please feel free to do that on Discord. I don't know if this chat is going to remain here forever, but if you could share that on Discord, I'm pretty sure people will be interested in coming back and looking at it. Uh, See, I can already see interest pumping up to learn that. But, um, the operating system should be below the hypervisor. I think you're referring to the model, the internet model, probably, where you are talking about the. I think you're confusing between two things here. What we are talking about here, or what the other image. Let me go back to that image. What this image is trying to say here is uh, those three blocks that you see on the top are different virtual machines. Let's just put it this way. I can give you a better example. I don't know if this will be very relatable to you, but when I was still in school and trying to experiment with the world of cyber security, I figured that there was a specific Linux distribution that was used very actively for the cyber security use cases, right? But I did not want to really use it. I did not want to install that on my machine and uh, use that on a daily basis. So I decided that I needed to look for an alternative and figure out a way that I don't really change things on my machine here, but I want to set a different interface somewhere wherein I can just go use it whenever I want to and then delete it completely. So that's when I decided to install virtual machines. And in when I'm setting up my virtual machine, I have an option to set up my operating systems. That's what I'm referring to here. So the three blocks that you see, each one is a operating system. Each one is a virtual machine. I'm sorry, with operating systems of their own, and applications live inside of those virtual machines. I hope that I was able to answer your question. Okay, I see a question here. Hypervisor as a software which needs to communicate, right? So imagine it this way: if this is a laptop that I'm using right now, and I have virtual machine somewhere allocated, the operating systems that installed in the virtual machines is not really what is installed in this interface that I'm using right now. So I have a different interface setup for my laptop, which takes care of me installing operating systems for myself or doing any kind of kernel operations and all of that, right? So I think I was able to explain a little bit about what I'm trying to say here. But those operating systems that you see are completely only related to the virtual machines, but there is always an interactive interface for the hardware on the whole, or for the machine on the whole, where hypervisors are installed and you do all of your hardware related operations. If I was able to explain. But keep the questions coming in the chat. If we are not able to find anything, we'll go back to chat GPT, we'll Google, we'll do all of those things and figure out. And I'm pretty sure there are other folks in this chat who can also help answer those questions. Oh, looks like you got that. Amazing. There's also a definition apparently here of hypervisors. Go read about that. I'm pretty sure VMware does a very good job in explaining things that they do. Sweet. That's it. And that's happily or sadly the way we end this session. I'm going to look at the stream one last time, and also because all of you stayed here for this amount of time, you were really, really, really interactive. I thought we could do a surprise prize giveaway at the end of the stream, and I think this is the perfect time for us to do that. But before I tell you how we're going to do that, I'm going to quickly scroll back to see if there were any last questions that came up, and then we'll get back really quickly to the surprise prize and call it a day. Um, um, See, looks like there are no questions. I'll also give you a couple of minutes to catch up. But we're going to do, if you've not been around for other sessions at this Global Hack Week or other Global Hack Weeks, we have a way of giving away surprise prizes. to folks who are really active in the chat, who are really active in the community, who are really active during Global Hack Weeks on Discord or here. It's just a way for us to thank you for being such an active part, answering questions, and really being so enthusiastic about the things that we are running here. But here to kind of one second, I think there's a question. I'll just quickly get to that. Can we get access to yesterday's and today's videos? Yes, of course. All of these sessions happen parallelly on, or it's streamed together on Twitch and YouTube. If you now go to YouTube, I can also link you to that. YouTube auto records all of the streams that we do. So if you go to this link on YouTube, I just dropped it in the chat. If you go to this link on YouTube, or just go to youtube.com, search for Major League Hacking, go to a section that's called Live. Click on that. You will see all of the sessions that have happened today, or I should say from the time that we started our YouTube channel. All of those sessions are there. They're also split up into playlists after we are done with a particular Global Hack Week. So that's where you can find all of the good content. Going back, catching up with the chat quickly. Oh, yes, of course. The pizza slide. Let's get to that here. If anybody wants to take a quick screenshot, you can do that here. I was also trying to figure out a way to get the cute Peter the pizza thing here. Maybe giving too much of a shout out here to a particular guild. Sorry if any of you run other guilds and I did not really give you that much of a shout out, but I was trying to get that somewhere here to get everybody excited, but I kind of really forgot honestly. But yes, that's what it is about virtualization and pizzas and aircrafts for today. Going back quickly, one last scroll through the session, to the questions. Twitch. That's correct. It's also on Twitch, but I think Twitch only maintains recordings or keeps recordings for 30 days or maybe 60 days. So it'll all disappear from there a little later, but it's always there on YouTube. YouTube again uses cloud, and I know that you already know, but yes, giving you another example of how things are working. Interesting question. How many clouds have you accessed yet? And would you like to share any review, like all of those? Let me think. I have particularly used AWS, Google Cloud, IBM Watson for a bit. But here's how I think of cloud interfaces when I use them, because most of these cloud interfaces have the same thing for you to deliver. The performance also is kind of the same. Maybe the pricing is where a lot of people, pricing and support is where a lot of people make a decision to use one over the other. But that's all a problem that enterprises have to deal with, and a lot of things that they kind of decide on. But for me, I'm looking at, or I kind of tend to use cloud providers which have better UI and better resources. Let's put it that way, community resources. So when I have I have a problem, I can Google and figure out answers to it. If there's a cloud platform that can give me that kind of flexibility and give me that kind of a support, not through their official support, if I can Google and figure out answers to several questions, that exactly I'm going for. But to be very honest, all of these platforms are really, really popular these days. There's support for you all over the internet. So I personally don't have a preference over all of these popular ones, but we just wait in the chat to see if anybody else has a preference like that. But all of them work really good, to be honest. Sweet. I think that's all the questions that we had. So we're going to do this real quick activity for a couple of minutes, and that's how we're going to decide our winner for the surprise prize giveaway, which is, if you've been around for other Global Hack Week streams, today in Global Hack Week streams, opening and all of those, you may have noticed us MLHs on the streams, or streamers on the stream. That's a weird phrase, but we would have noticed the person on the other side of the screen come up with a question and ask you to kind of post an answer to it, and we kind of randomly select one person as a winner, or a most creative answer as a winner, right? But to kind of change things a little bit, I wanted to ask you all to suggest some cool questions or ideas that can become a way for us to give you, or give maybe folks in the next Global Hack Week surprise prizes. So to kind of summarize, you're going to tell me of a cool surprise prize giveaway question or an idea. And we're going to read through some of them, just kind of hang around and have fun for the next 5 minutes, and then randomly select one winner, or probably have you all vote for a winner, and then take it up from there. Does that sound good? I'll let you all. uh, Not really. I can say I wasn't creative enough today, so I decided to have you do the creative side of things. I know all of you are way more creative than I am, but let's go. Let's do that today, and let's just hang out for 5 minutes. And you can still ask questions if you have anything related to pricing, related to communities, anything interesting that you want to share, and then we'll select a winner here and then call it a day. I'll By the time you'll all catch up with the stream, I will go back, really scroll through all the questions one last time to make sure we did not miss any there. But if in case I missed any questions, please feel free to repost that in the chat, because there were a lot of things that were happening in the chat and I may have missed one of your questions. Just give it to us, or give it to me right now, and I can definitely help you with any questions that you have. Um, oh, 404 is back. Amazing. Okay, we have one answer here which is saying meow. Okay. The person who spams most pizza emojis. Okay. Um, Especially for the new people. Okay. Can you imagine challenges? I think this is a question here about monthly, weekly challenges. We do run month-long hackathons, or I should say, we did run a month-long hackathon in November. We also are running one in December. If you've not had the details come out yet, this may be a spoiler. But we do have something running like that. We don't have a weekly challenge. We do have a weekly challenge in terms of what you see as Global Hack Week challenge. If you were to go to globalhackweek.mlh.io or ghw.mlh.io/challenges. This is the page. So if you were to go to this link, you will see challenges listed there, and that those challenges are accessible throughout the week or till the end of Global Hack Week for you to go use. So that's weekly challenges, and we run month-long contests or month-long hackathons. That gives you more amount of time to go use and experiment with a lot of technologies and come back with your hacks. And there's of course a lot of winning opportunities as well. Sweet. Let's go back and read through the chat. And I'm hoping you are also reading through the chat to kind of decide on your favorites. Where's the person who says meow? What's your most used language? Most, uh, okay, another question here, but keep those ideas coming. Pricing for any clouds, if you said before, like regarding creating and uploading. So if you were to use a typical cloud platform, once you log in, you get those free credits to begin with, and that I think is really enough for you to experiment with a lot of things and keep it hosted for a while. But if you really Google the name of the platform with the word pricing, you will see a list of pricing there. It kind of is dynamic in terms of the traffic and everything that you're going to get. But a disclaimer that I would want to give you is you really need to read through and understand the pricing a little bit. And I don't really know that really well to tell you that offhand, but make sure that you read through all of these things, because some of these services that you may use may be really intensive and may be really highly priced. So make sure that you read through all of this. And once you're done using it, make sure that you deallocate those resources or kind of disconnect those resources, so you're not really still being charged for what you're not using. But good point, and a really good reminder that I wanted to give all of you about that. Cool. And I think there'll be other people who would also want to answer that in the chat. So maybe also wait for all the other answers. Cool. I think we have a lot of ideas already coming in. So like we do all the time, I'm going to close my eyes and maybe scroll through the list here, and I'm hoping I land my cursor on an idea, not a question. So we're going to do that, and wherever it lands, we'll comp them the winner. Are there more coming in? Cool. I think there's not any more that we're waiting on. Sweet. So I'm going to close my eyes and start scrolling, scrolling, and scrolling. And then wherever it stops, we're going to call them a winner. And congratulations, you are the winner for today. Congratulations on getting your surprise prize. What you need to do now is click a screenshot of this, of your chat being pinged on the stream. Create a Discord ticket. You have to go to this link. I can also post the link to our Discord. So it's discord.mlh.io. Go there, look for a channel called Support Tickets, and just share the screenshot and let us know that you got your surprise prize during the stream, and we'll add you to that list, and it'll reach you really, really soon. Wait, were there more that were coming in? Ta-da. No. Okay, cool. So that wraps up what we did. I'm hoping you were able to screenshot that. Let me know in the chat if you weren't able to screenshot that, if I was too fast with unpinning your comment. If not, we can pin that again and then you can create a ticket with that screenshot. But if not, congratulations. You got your surprise prize for today. I see another question here, which I scrolled through really quickly. Let me go check what it was. The glitch in the MLH homepage, I am not sure of what you're seeing there. Let me just open it up and find out. Now, when you see the homepage, I think you're referring to mlh.io. It's working as expected for me. If you are seeing anything specific, can you probably create a support ticket as well to let me know, or maybe post this on a channel somewhere and tag me? My sorry, my Discord username is Siddharth from MLH. You'll see me as Siddharth from MLH. Maybe just tag me there and I can quickly look at it. But it seems to be working fine for me right now. Oh, wait, sorry. This was your question. I'm sorry, I misunderstood. But yes, good question. But we already have a winner here. That wraps up our session for today. Thank you so much for joining. I hope you go back with a lot of aviation references, if not anything else, and also have a little bit of an idea of how cloud came into picture, how things evolved, and other terms that may not be directly related to cloud on a daily basis, but it's probably worth knowing how things reach the point that we are at today. Thank you so much for coming in today. Stay tuned for other sessions. I know there's one coming up in around 40 minutes, if I'm not wrong. Yes, somewhere around 40 minutes. Dikshita is going to be on MLH Discord to play the No Light mini event with you. That's going to be super interesting and super fun to be around. Make sure you are there if you can. If it's super late or super early for you, make sure you get that rest and come back later for the Today in Global Hack Week stream, which I think should be happening right after that. There's another stream that we have after that. So stay tuned. You know where the schedule is. It's on globalhackweek.mlh.io/schedule. Go there, check out all the good stuff that's happening. Keep your feedback coming in. Make sure to meet new folks, make friends, learn together, and keep the fun going on. That's my time. I will see you all in the next stream probably or sometime later, but we'll catch up really soon. I'm always there on Discord. You can hit me up there. But that's my time. Thank you, and I'll see you later.